All right, in this lesson, we're going to continue our inverse functions. We talked about just the idea that you switch x's and y's, and that a one-to-one is when your original and your inverse passes a vertical line test. But we can tell that actually from the original because it has to pass a horizontal line test. So here are a couple of examples of just some random graphs, and here are the equations for these. And this is a linear. Linear, all of these are functions. They're all meant to be functions, so they all pass a vertical line test, but not all of them pass a horizontal line test. So they're asking whether this is a one-to-one. Yes, and our justification is it passes the horizontal line test. This is no, does not pass the horizontal line test. This one will pass the horizontal line test. This may go pretty flat, but it never is perfectly flat. So that is a yes. Horizontal line test. And this one is a no. It does not pass a horizontal line test. All right. So how do we figure out whether that's going to happen or not? So we're going to need to create our own graphs. So if we have this equation, we're going to try to determine whether the function is a one-to-one. So to do that, first thing we're going to do is we're going to graph the original. Graph original to determine that. So if we're going to graph a 2x minus 3, we have a linear equation, has a y-intercept of -3 and a slope of 2. So 1, 2, 1, 1, 2, 1. Okay. Okay, so there is our linear. Let me just solve that in a little bit. So there is our original function. Okay, so it's a function. It passes the horizontal line test. So is our function, our inverse, going to be a one-to-one? The answer is yes. So if it is a one-to-one, let's figure out what that is. So to actually find an inverse equation, our steps are right here. We're going to take our original f of x and we're going to turn it into a y equals. So y equals a 2x minus 3. And then I like to kind of separate out, here's where the original ends and here's where our inverse begins. That we are just going to switch our x and y because that's what we would do with our coordinates, so we do that with every single x and y. So our y value becomes an x, our x value becomes a y, and we are going to now solve for y. Alright, so we're going to add the 3 over. So that's going to be x plus 3 equals 2y. We'll divide each piece by 2. So those 2's are going to go away. This is where I like to kind of switch this around. So this is a 1/2 x plus 3/2 is 1.5. It doesn't matter if I leave it as 3/2 or 1.5. I'm going to put it as a 1.5 because it's going to be easier to graph my inverse because that's what they're looking to do here eventually. So there's my original. I'm going to finish it up with one last piece where I'm going to write it as f -1. That represents that we are talking about an inverse. So that's our inverse. And okay, so there is our equation. Let's graph that. So we have a y-intercept of 1.5. And then we have a slope of up 1 over 2, down 1, back 2, up 1 over 2. Try and make this graph a little cleaner. Alright, and then if we look at the 45, it's supposed to be reflected across that. Okay, and it definitely looks like that's the case. So this is our inverse. Okay, so same thing we're going to do on the last one is we're going to take this cubic, we're going to graph it, see what we got going on with this. So we have a shift of up 2 And then we're going to do outs and ups in order to graph this. So the plus 2 is taken care of, it's done. Now we're going to be cubing things. So we're going to go out 1 and cube it, which is 1. We go out 2 and cube it. 1, 2, 3, 4, 5, 6, 7, 8. And if we go left 1 and cube it, we are getting a negative 1. If we go left 2 and cube it, we're getting a negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so our cubic graph is looking something like this. All right, and then does it pass the horizontal line test? Yes, it does. So our inverse is going to be a function, so that means we're going to try and go ahead and figure out what it is. So we go back to the basic idea that instead of writing this, we're going to write a y equals x cubed plus 2. And then it is a one-to-one, so we're finding the formula, so we're going to switch our x and y. We'll subtract the 2 over. So minus 2 minus 2. So that's going to become x minus 2, so I just swapped those just to make it a little easier to do the math on it. And then we got to get rid of the cube, which is us cube rooting it. So y equals the cube root of x minus 2. So again, to finish this up, to fancy it up, let me make my inverse stand out. We're going to do f negative 1 of x, so the inverse function, inverse of f, is the cube root of x minus 2. Okay, to graph that thing, this is going to be a left and right shift. So this is going to be right 2. And our outs and ups are going to be based on the fact that we have to cube root something, and we would like to get a clean cube root. So if we're going to go out 1 and cube root it, that makes us go up 1. We'd have to go out 8 in order to cube root to go up 2. So 1, 2, 3, 4, 5, 6, 7, 8. That has us go up 2. If we go left 1 and cube root it, that's a negative 1 cube rooted, so that's a negative 1. And then we go negative 8 cube root it, and we get a negative 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Alright, so that graph is looking like that. Okay, so that's the inverse, and again, we can really double check because they should be perfect reflections over the 45. And they look like they are good reflections of that. All right. So we'll continue with inverse functions. We're going to do a little bit more detail of what inverse functions can do and then how we actually verify them in the next lesson.